Assalamu alaikum everyone. This is Probability and Statistics for Engineer course in the Department of Civil Engineering, International Islamic University. Today our lecture will be regarding hypothesis testing. Hypothesis testing is one of the widely used tests in statistics. Researchers use this test to either accept or reject their claim in the research. So this is a kind of threshold which we use to whether accept our research, our accept our claim or reject that. So let's start with hypothesis testing. Now let me give an overview of hypothesis testing. Let's say you have a population of certain area. So let me consider the population of Islamabad. In this population you might have a lot of young people, a lot of old people, and kids and all this. So a population constitute people of different ages. Now I believe that the population mean age is 50. So I say that when, as per my observation, the mean age of these people in population is 50. So this is the claim. I'm claiming this, and this is for whole population. For whole population, the mean age is 50. Now, what I do, I take a random sample. I take a random sample of this population. For example, if a population of certain area is 1000, so I take a sample of 100 people, let's say. So out of 1000 I take a population a sample of 100, and then I observe that the sample which I took, the mean age of the people in that sample, that was a random sample, and the mean age of people in that random sample is equal to 20. So we say that the population mean we normally represent by mu, which is equal to 50 though. So the population mean is 50, but when we took the sample, so the sample mean was 20 instead of 50. Now since this x bar, which is 20, it's not very close to 50, so what we do, we reject the hypothesis because that is not close to the population mean. Or we can simply say that the sample is not a true representative of whole population. So when we do this kind of process, we basically do hypothesis testing. But we cannot just simply reject that x bar, which is far from mu. We need to have some mathematical calculation. We need to have some benchmark or some threshold value on the basis of which we reject or accept our hypothesis. Now what is hypothesis? It is a belief. It is a claim about a population parameter. Here the population parameter of interest is mean, and that might be proportion. For example, proportion of male and female in certain population, are the variance value in a population. So whatever we do some analysis. As I said, we do analysis as a researcher. If we accept or reject our claim, we need to define that. We provide one statement that whether this population mean is equal to 50 or that population mean is not equal to 50. Or we can say this person can say that I believe the mean GPA of this class is 3.5. So mean of this class is 3.5. So if the class constitute 35 students, so the mean GPA of this class is 3.5 if someone calculate that and claim that. But if I take a sample of 10 students out of that 35 students, and then I calculate the mean of a sample, so that is 3 but not 3.5. So whether these three are, this is true representative of the whole population or not, we need to perform some mathematical calculation for that. Now, as I said, the calculation, it's the whole process is like the claim the population mean age is 50. So we define a null hypothesis. I will explain what is null hypothesis. Now, our claim, if we say okay, mean age is 50, so that is our claim, and we say we consider our claim as true, so we represent it as h naught, which is a null hypothesis, which say that our claim is true. So we represent it like this: h naught and mean, a population mean is 50. So this whole is our claim. Sorry, this is our claim, and our claim say that mean is 50. Now if, and that 50 come from this whole population. Okay, so now we select out of this some sample, which is a random sample. We don't take exactly this or this, first 3 or first 4. We take randomly different number out of there. For example, I take this, I take this, I take this, and I take this. Okay, so that is our random sampling. It's not about the characteristic of someone. It's not like we have to take people of some fixed characteristic. We take the people, a sample of this whole population, which is random. Now suppose if I calculate the mean age, and that is x bar 20 instead of mu is equal to 50. So is x bar 20 likely if mu is equal to 50? Is it true? Because that was our claim and that we have calculated from sample. So if that is not, if 20, because 20 is, of course, that is obvious, 20 is very far from 50, so there is a very huge difference between 20 and 50. So we can say that this sample is not a true representative of whole population, and we can reject our claim. And our claim was a null hypothesis, and null hypothesis say mu is equal to 50. So no, mu is not equal to 50. Now what actually is null hypothesis? It begins with the assumption that null hypothesis is true. We begin that mu is equal to 50 because that is our claim. So we can also say that mu is equal to 50. We can also say that mu is equal to or greater than 50, or we can also say mu is smaller or equal to 50. So all three of them are correct, because we can there might be a possibility that mu is equal to 50, mu is greater or equal to 50, and mu is smaller or equal to 50. But all of these will include the equality sign. May or may not be rejected. So if that is 50, we can either reject that by performing some statistical analysis, and we can accept that. So written with sign equal to sign, even if greater or equal to, so there should be always equality sign. For example, h naught, that is null hypothesis, which state that mu is equal to 3. So if we say that 3 is a GPA, so for a class I claim that mu is equal to 3, that is a GPA, mean GPA of the whole class is 3. So that is my claim, so I represent it in that way. Now alternate hypothesis is opposite of null hypothesis. Whatever we define as a claim, whatever we define as a null hypothesis, alternate hypothesis will be its opposite. So it will always have inequality sign, that if our claim is mu is equal to 50, so in our case of alternate hypothesis, that will be mu is not equal to 50. Or that is also a possibility that if that is not equal, if that is 50 and our alternate hypothesis that is not equal to 50, so mu might be greater than, so mu might be greater than 50, mu might be less than 50, because our alternate hypothesis states that it is not equal to 50. So it is designated by HA. So if we define our null hypothesis H naught, we will define that is HA. So R with dot, and mu is not equal to 50, or we can say mu is greater to 50, or mu is smaller than 50. So that's like this. So an example H, that mu is for a GPA, that mu will be smaller than 3. Now how we basically identify hypothesis. So first we do state our question statistically. Now our statistically mean that we have to take the either the average value of a population, either the proportion, or either the variance of population. So in example, is the population average amount of TV viewer is 12 hour. So whether in whole population the mean number, the mean or the mean time of watching a TV is 12 hour for a people of certain area. So if someone perform a research, if someone carried out a research and he compute that mu is equal to 12, that is as a for a whole population, on an average they watch the TV for 12 hours. So if we then take the sample of this from that population and take their consent and see whether that mu is equal to 12 or not. So first we define the it's statistically the question, so that is this one. Now state opposite statistically. So if we claim that mu is equal to 12, so the opposite of that will be mu is not equal to 12. It means that they are mutually exclusive and exhaustive events. So what we do then select end state alternate hypothesis, and then we write it more formally that HE, that is alternate hypothesis, and that mu is not equal to 12, and H naught, which is mu is equal to 12. You can also write that above of that. You can either state null hypothesis at the third and alternate hypothesis in the fourth. Now what is the basic idea behind it? How do we mathematically verify, or how we do mathematically accept or reject a claim? You remember a normal distribution. So in case of a normal distribution, if that is not a standard normal distribution, we say that mean falls exactly at the line of symmetry. So the mean population, if we talk about mean population of the age of whole population, so that is 50. It means our claim is mu is equal to 50, which is H naught, and that will fall exactly at the center. Now if we perform some experiment, if we take a sample of that and then we calculate the value of mu from that sample, so what we do, we write it on x-axis if it is x bar, if it is the sample mean. So we write it here, for example, x bar, that is sample mean, we calculate, and that x bar equal to 20. After performing experiment, so that is equal to 20 on this line. It may fall somewhere here. Now there is a difference between 50 and mu. Now what the procedure actually says, there should be a critical value. There should be a critical value. For example, a critical value is somewhere here. And how we do define that critical value? Same for the left side and same for the right side. We will define that in our later slides. So if the value sample mean fall to the left of that critical value, then it mean that it is most unlikely that we accept H naught, mean that it is far from population mean, so we cannot accept that, because we say that in the sample the mean is much different than the population mean. So that's not true, our claim is not true. Now if that fall, if the sample mean fall in that region, within that region, so it means that there that the population, the sample mean is quite close to the population mean, the sample mean is quite close to the population mean, and we can accept our claim. So same for the left side and same for the right side. It depends that whether a sample mean is greater than the population mean or smaller than population mean. Now formally calculating that critical region, we also need to define another parameter, that is level of significance, which is alpha. It defines the rejection region of the sampling distribution. In the previous example, I can say that if the critical value falls somewhere here, we will calculate that critical value from a table. So if we define the critical, this is the critical value on x-axis, and so the area to the left side, the area to the left side of that critical region in case of negative side is the rejection region, and this is rejection region in case of plus side, so if that mu is greater. Now if the value of sample mean fall in this rejection region, so we will reject our claim. So alpha, that is significance level, we either say alpha is equal to 5%, or we can say alpha is equal to 10%. So that is a level of significance, that is a kind of input we say, or we can say that there is a 5% probability of uncertainty in our claim, or we can say there is 10% uncertainty in our claim. So that is usually selected by a researcher. He can put it 5%, he can put it 10%, and what they do, that provide the critical value of test. I will explain later how to calculate the critical value. Now we can see here for a level of significance alpha, if mu is greater or equal to 3, so if that is our claim, that the population mean is greater or equal to 3, so but opposite of that is alternate hypothesis, which say that mu is smaller than 3. So we will deal in that case to the left side. Remember that we will deal to the left side region in that kind of scenario. So if we have a scenario that mu is smaller or equal to 3 and alternate hypothesis is mu is greater than 3, so in that case we will deal with the upper portion of the normal curve, or we will deal with upper tail, so we will perform upper tail test. Now there is also a possibility that H naught if our claim is mu is equal to 3 but alternate hypothesis mu is not equal to 3, so in that case we will deal with both the tails. We will check our test statistic in both of the side, on the left side as well as on the right side, and we will, and these both sides will define our rejection region. Okay, in case of one tail test for a sampling distribution, if we have a normal distribution, so that H naught is our claim, that mean fall here. But if that is a critical value that we will define in our later slides, so if value fall within that region, it means that our claim will be rejected, because that is a rejection region, and the remaining area, that is a non-rejection region. So if a sample value fall anywhere in that region, so that we will accept that. For example, if that is H naught and our sample statistic fall here, so we can say that we will accept our null hypothesis. Now, if the value fall here in the rejection region, we will say that we reject our null hypothesis. Now, what is test statistic? That we actually calculate test statistics, and this is a value that we have previously done that in calculation of z-score. We compute that value, as I said, for a, because we normally deal with the normal standard normal distribution. So in case of standard normal distribution, our mean will fall here, so mu is equal to 0, and then we will check our z-score value on both sides of that. So that is actually same z-score value which we obtain from a sample mean. Then we also need to know population mean, and divide by sigma x, which is the population mean, and divide by sample size. Okay, so if we are given all these, we can calculate z statistic, and z can either be negative or positive. So if z is negative, it will fall somewhere here. If that is positive, it will fall somewhere here. Okay, so we have already covered that portion to see where the value will fall to either reject or accept that. Now let's see how to calculate that z statistic value or z test value. So finding the critical z. Now we already calculated our z test value. Now as I said, we need to calculate the critical z and then see that whether our z value fall to the left side or to the right side, whether our z-score value fall within rejection region or in acceptance region. So critical z value will define the rejection region. That rejection region will be defined by critical z value. So as you know that for a standard normal distribution, mu is 0 and standard deviation is 1. So if we have a data, we can use that and we can calculate a z-score value. Now for a researcher, if he define alpha level of significance, as I said, we have importance of level of significance. So the level of significance, if I as a researcher define that is 0.25, so the whole area under the curve is 1. Now the alpha value will if we say that alpha is 0.25, so the region to the left, to the right side, is basically 1 minus 0.25, and that 0.025 is 0.975. Now 0.975, what actually that 0.95 shows that this whole region cover 0.975. Now 0.975 is the value that start from 0 and move toward the right side. So in table if we have a value 0.975, that will give us the respective critical value. We can also say critical z critical value, and then any value of z beyond the critical value, if that is in case of upper tail, we in this example we see upper tail, so any value to the right side of z critical, any value from the test statistic or z test which is to the right of that critical value will be rejected, and because that will fall in the rejection region, and any value to the left of that critical region will be accepted. Now if we have this scenario, so 0.975, we will see our normal standard normal probability table. So 0.975 is here. Now 0.975 correspond to the z value, that is 1.9 and 0.06. So z value or z critical value is 1.96 from this table. Now it means that in case of normal curve, if mu is here, that is mu is equal to 0 and standard deviation is equal to 1, so z critical value is 1 point, I will use another, z critical value is 1 point, z is equal to 1.96, so that is a critical value. Any value which we calculate from this equation, z is equal to x bar minus mu divided by sigma by under root n. So any value of this z, if that fall here, that will be accepted, and if that value fall here, that will be rejected. So that is a rejection region. So if that value is rejected, it means our null hypothesis is rejected. If that value is accepted, it means our null hypothesis is also accepted. So in that way we can either accept or reject our claims. So we will talk about one example in our next lecture. Thank you for now.